solve it in two different ways, okay? The first way we're gonna solve it is leaving it as it is and using our square root property. Okay, so if I were gonna use my square root property to solve this, what do I need to do? Take the what of both sides? Take the square root of both sides, exactly. I wanna take the square root of both sides. When I take the square root of x squared, what happens? Squared cancels out, so I'm just left with x. When I take the square root of 121, what is the square root of 121? And plus or minus 11. So how many solutions does this quadratic equation have? There's two. So remember, like I was saying, for quadratic equations, you're either going to have two solutions or you're going to have one solution. This one has two solutions, plus and minus 11. And what type of solutions, what kind of number is our solution? A real number or a complex number? It's a real number. It's a real number. Or when we talk about real numbers, it's anything on the real number line, and it's what everybody's used to, all the numbers everybody's used to working with, okay? In a few minutes, we'll talk about complex and what that means, all right? But for this one, we have two real solutions. All right, so this is using our square root property. When I use my quadratic formula, it needs to be in this form right here, this ax squared plus bx plus c, because I'm going to pull out what a, b, and c are and put those into my formula, okay? Anybody remember what my quadratic formula actually is? So, quadratic, so there's a difference. So this is one of my little pet peeves that makes my eye twitch. Make sure everybody knows the difference between a quadratic equation, which is what these are, quadratic equations, and their quadratic formula. The quadratic formula is what we're going to plug those a, b, and c values in. It's going to solve it for x, okay? So my quadratic formula, if you look it up on YouTube, it plays a lovely little song. Does anybody remember what my quadratic formula is? Negative b, should we sing it? No. Plus or minus the square root of all over 2a. There we go. And all over by 2a. So not just this part, but the whole thing is being divided by 2a. Okay? The whole thing. So there's my quadratic formula. So if I were to pull out a, b, and c from this one, and I put it in there, after you simplify everything, you should still get positive and negative 11, okay? All right, so this was slide 6, okay? So it says, recall when writing x-intercepts for any function, they are the order pair x0 where x is the x-intercept. Okay, so this is something that's gonna come up for the rest of the semester. When we have functions, and we have the function given as an equation, we need to be able to find the x and the y intercepts, which we've talked about before when we talked a little bit about it for exponential and log stuff, but we're really going to talk about it with polynomials and with rational functions, which are basically the last two functions we're going to talk about, okay? So when if we have a function given as an equation and we're trying to figure out what our x-intercepts are, what does our y have to be equal to? 0, exactly. So basically, we make so for our quadratics here, this is, the reason I put this slide in here is to connect the quadratic equations that you guys are doing on Wednesday to the quadratic functions. So if I have a quadratic function, like x squared plus 4x plus 7 is equal to f of x, the way that I can figure out my x-intercepts is I can make it equal to 0 and then solve for x, okay? The same way for the y-intercepts. To find the y-intercepts, what do I need to make equal to 0 then? The x's, exactly. So to find the y-intercepts, I'm going to make it equal to 0. But for here, we're going to focus on finding those x-intercepts. And well, the way that we do that is we basically make that whole equation equal to 0 like we did here and then solve for x, okay?
Okay, so yeah, this is what I put. For the quadratic, below 2x squared plus 11x plus 12. I would use 11x and 12 to find the two common factors that can go into both numbers. And then yeah, those two numbers would be used for the x-intercepts.
Anyone want to second that idea?
Which is 0 supply.
So I definitely think we want to set the equation equal to 0, right? And then how do I factor that bad boy? 2x squared plus 11x plus 12.
We would use, hold on.
2x plus 3 and x plus 4.
Sure, you can try the trial or error method, right? Or you could use the AC method, or you could use the quadratic equation. Right, all methods that would work. Right, but the idea here is that the zeros, or the x-intercepts, come from the factors of that function, right?
Yes.
It would be 3 and 4? No.
It would be, I think, 11 and 1.
You're forgetting the 2, Ian. There's a 2 in front.
Oh, yeah.
Yeah.
2x plus 2.
Alright, I'll be back.
Okay.